Section 11.4, Post-Hoc Procedures. So remember that when we reject the hypothesis for an ANOVA, it's somewhat unfulfilling because we do learn that at least one of the means is different from the others, but we don't learn which one, or whether it was just one or possibly more than one that were different. We don't learn which one is the largest or the smallest. We don't learn anything about that. So for this reason, we often follow our ANOVA tests up with an exploration to look further into the relationship of the groups to one another. So this is what we call a post-hoc analysis. It's analysis after we have looked at the data and determined, of course, we had a small chance of making an error, but we have determined that at least one of the means is too different from the others to be convincingly explained by chance. So we only perform this if we reject the null hypothesis. And the goal is to determine which groups have different means from the others, which have the highest and lowest means, etc. So we don't do this if we fail to reject, because if we fail to reject, then we're saying that they're all the same. So it's only if we've determined that something's different that we would want to continue exploring that. The process that we use is called the Tukey honestly significant difference approach, and for us, it's called the Tukey Hsd. That's what you'll see in StatCrunch. That's the procedure we're going to use. What it does is it provides a set of simultaneous 95% confidence intervals, and these intervals are used to determine which means are greater than the others. So let's jump right into an example. This is a really interesting example. It says some researchers hypothesized that some people do not like machines if the machines seem too human-like. So a sample of people were asked about a new type of computer. The control group was told that the new computer is just like a regular computer, it's just more powerful. And the second group was called with agency, and those people were told that the new computer could plan ahead and carry out some actions on its own. And the third group was called with experience, and they were told that the computer could feel some forms of hunger, fear, and other emotions. After being told about the new computer, everyone was given a questionnaire, and from the respondents' answers, they extracted a scale that measured how, quote, unnerving they found this machine to be. It's the same machine, so these people were just told different things. A high score suggests that they were very disturbed by it. So we've got some box plots here, and then we've got an ANOVA table with a Tukey Hsd analysis on the next page. So what I can see from the box plots is I almost just feel that by a very, very quick analysis here that I might come to the conclusion that this one is very different from the others. But the question really becomes, are these different from each other? Or are their means maybe close enough together, again, that maybe it was just due to random chance that there happened to be a few more people that randomly got chosen in that with agency group that are, maybe they're just afraid of everything or something like that. So this one, I feel like I can almost jump out on a limb and say, yeah, that one's definitely different, but I'm certainly not sure about these lower two. And I don't have anything other than just my gut feeling to make any of those statements right now. So we definitely want to go through the procedure and get some numbers. Okay, so they've ran an ANOVA test on it, and they've actually clicked the Tukey Hsd button. So it's a button that's on your ANOVA test page. So you can click it when you need to. And so they've done that, and we've got all that information here for us. But first, let's check, does this even meet the homoscedastic condition in order to perform an ANOVA test? So remember, on that one, we want to take the minimum standard deviation, this is the max, and make sure that's less than or equal to twice the minimum. So let's see, our standard deviations are here in this column. The smallest one is about 0.25. And the largest one is 0.45. So it looks like 0.45 would be less than or equal to 0.5. So it's pretty close, but it does make it. So we're good there. And then the other condition we have to look at is the sample size. So does this meet the sample size condition? If I look at all of my n's, not a single one of them is bigger than 25. There was only 15 people in each group. So because all the n's are less than 25, we have to assume normality to continue. And again, there are ways to test that, but we aren't learning them this semester. And so we would at least we would have to make a note that we are proceeding with caution under this assumption that the populations are normally distributed. And maybe there would need to be some extra investigation into that before we could finalize our answer. I certainly wouldn't want to publish it after this quick test. Okay, let's go ahead and write our null and our alternate hypotheses. So my null is going to be that all these means are the same. So I'm going to call them the mean of the control equaling the mean of the with agency. So I'm going to call that A for agency. And then I'm going to call the last one experience. And my alternate hypothesis is that at least one of these is different. I should probably say mean here. Okay, so again, they've already done this. So it says given the f-stat and the p-value, what should our conclusion be? So it looks like since p is very, very small, p is definitely less than 0.05, we will reject the null. So our conclusion will be that at least one of these means is different. But you can see how that can be somewhat unfulfilling. Like that's what I thought from the very beginning. I kind of thought that the with experience one was different from the other two. I really still don't know anything at this point further about, are the other ones different? Maybe they are. So this is when we'd want to use that Tukey option. And notice what it does is it gives us 3 different confidence intervals. So these are the different intervals that are being created. Oops, I'm going to erase that. Let me actually parenthesis in the correct values here. And what you have to be very careful about is how they write this. So these first ones say control is subtracted from with agency, and control is subtracted from with experience. So you have to understand how that wording goes. If you have control subtracted from agency, what that means is you're taking control away from agency. And on the next one, it would be control away from experience. And it matters the order that you say that in. What we want to do, what we focus on is 0 in there? So for this first one, if we do agency minus control, notice that this one goes from negative to positive. That means 0 is included. So what we've got there is we've got the mean of the agency minus the mean of control equaling 0 is possible. There are other values that are possible, but this is one that's possible. If I subtract 2 values and get 0, remember from our prior confidence interval testing and stuff, that means that these could be the same. So these means could be the same. When we subtract control from experience, notice on this one it's all positive values. So it's positive values and it doesn't include 0. So what that means is if I subtract these, the mean of experience minus the mean of the control, I get everything positive. And what that tells me is that the experience is larger than the control. And in my very last one, again, everything stays positive. So if I take my mean, this one is agency subtracted, so it's agency subtracted from experience. So if I take my mean of experience minus mean of agency, and I get all positive values, what that tells me is that the mean of experience must be larger than the mean with agency. So what we've got now, to summarize all of this, it says, is there evidence to support the researcher's claim that the with experience group would be the most unnerved? And I would say yes at this point. People felt on average more unnerved by the experience group, than either of the others. The other two were so close they could possibly be the same. So even though visually it did definitely look like the with agency was slightly, like the whole box plot was slightly higher than the control, what we're saying there is that the difference between those two means was so small that maybe that was just due to chance. That was kind of due to a fluke in our sampling procedure. But the other one, the with experience, was so far from the other ones that there's no way that it's actually the same.